Okay, I think this is on. Okay, so it says the problem has 50 milliliters of that much hydrochloric. Oh, sorry. At 22.5 with 75 milliliters of sodium oxide at 22.5. After the solutions mix, the temperature rises to 26.8. Similar solution density is 1.0. The specific heat is 4.18. Calculate the enthalpy change, kJ per mole reaction for neutralization. And then the reaction is right there. Okay, I'm gonna try not to move my iPad too much because it might make too much noise. Okay, so first we have to find the limiting reagent. So we can find that by moles of hydrochloride and moles of sodium oxide. So we get each one. Okay. This, and we multiply it by the volume. It's going to be in liters. So you just multiply. Oh, same. Okay, it's not on. Divided by. Okay, and then we get 0.100 liters, and this one is 0.075. And then the answer to those two is 0.00 moles. And now the other one. .070 moles. We can see how hydrogen chloride is the limiting reagent. And now we have to add the total solution mass. So we have 50 milliliters plus 75.0 milliliters is 1.25.0 grams. The temperature change is, the final one was 26.8 minus the initial one, which is 22.5, and you get 4.3. Okay. And now you're going to get the Q solution, which is also equal to MC temperature change. You just plug those in. So we have 25 times, which one was it? 4.18 times 4.3. that equals to 2246.75. Multiply. Wait, sorry, I think it's divide. Yes. Divide by 1000 to get kg, and that is 2.24675. Okay, and because the solution is warmed, it like the temperature was raised, heat released by the reaction, so that means that it's going to be 26.75. And now the enthalpy per mole of reaction. So you're gonna get the limiting region. Moles reacted is this much. So then we're gonna get formula. You're gonna plug in all your answers. Oh, sorry. And that equals -44. Per mole. You can convert that to kA, so we're gonna by 1000. That equals -449 per mole. And okay, I'll highlight this. Oh, it's not working. There you go. Okay, next problem. It's all the way over here. Okay. Okay, so we have our action. So it says we have this information: burned if 25 grams of propane is burned in excess oxygen, how much heat is released? Also, how many moles of CO2 are produced? Okay, so we're gonna convert the mass of propane, 2 moles. So we have C equals 12.5